So let's look at our last example here. And one of the things I want you to quickly notice is that the dipole moments for each of these three molecules is 0. So right away, what that tells me is that all three of these are nonpolar. And I can look at each one of them and see that there's no lone pairs on the central atom. The carbon in the middle of each of these is only bonded to one ion, right? So, or one element. So I've got CF4, CI4, CBr4. All are nonpolar. They only do dispersion forces. And so I can't differentiate based on the type of forces. I can't differentiate based on the dipole moment because, again, nonpolar molecules are 0. The only thing to differentiate these is going to be formula weight. And so formula weight is what I'm going to have to do. And so when I go to calculate formula weight, 12.01 for my carbon, 19 for each of the fluorines times 4. So that gives me 88.0. Here again, 12.01 for the carbon. Iodine is 126.9 times 4 is going to give me 519.6. Here I've got 12.01. Each of the bromines is 79.90. And so that's going to give me 331.6. And so this is the biggest. This is the smallest. And so I would expect this to have the lowest boiling point, this to have the highest boiling point. And so B would have the highest boiling point, the lowest vapor pressure. A would have the highest vapor pressure, the lowest boiling point. So remember, dispersion force is about the size of the electron cloud. So that electron cloud gets bigger, it can be distorted more. And then it can make stronger dispersion forces. And so, again, this is going to be something that you look at with the lab where you're comparing carbon dioxide and oxygen, both nonpolar molecules. And so you'll be able to see how that plays out in kind of a macroscopic situation. As always, thank you for your time.